Hello, everyone. I'm Amir Kermany. I'm the Technical Director for Healthcare and Life Sciences, and I'm joined by my colleague Mo Steller from Microsoft. And today we will be talking about automated patient risk adjustment and Medicare HCC coding using clinical notes. So my role at Databricks is as a technical director for healthcare and life sciences. I am primarily focusing on building solution accelerators and solutions based on repeatable patterns that we see in the space, mainly focusing on adoption of the Lakehouse data architecture and machine learning and deep learning in life sciences. Mo?
Yep, thank you so much, Amir. Mo Steller. I'm part of Microsoft. I lead an industry vertical healthcare within the customer success organization in Microsoft, focusing primarily on AI ML use cases. Really anything within that industry around population health examples, the example we showed today around HCC coding and risk stratification, but also NLP, which is one of my passion areas.
So for the agenda today, I will give a brief introduction to Databricks and our partnership with John Snow Labs and Microsoft Azure. And then we will be focusing on a specific use case on patient risk adjustment and Medicare HCC coding. And we will walk you through the solution architecture and solution accelerators that we have jointly built to see how we can leverage unstructured data, such as medical notes, for these applications. So first, who are we at Databricks? We are the data and AI company and the inventors and pioneers of the data lakehouse architecture. Gartner has recognized Databricks as a leader in both database management systems and data science and machine learning. And we now have more than 3,000 employees worldwide, supporting over 6,000 companies globally. And we are fortunate to have more than a fifth of these customers being in the healthcare and life sciences space. The adoption of our platform spans all segments of this ecosystem, from pharmaceutical companies such as Amgen to government organizations such as NHS Digital in the United Kingdom. As a matter of fact, we're seeing a rapid growth in investment in data and AI within the payer and provider space. For example, more than 4 out of the top 6 payers in the United States are using Databricks for applications such as fraud, waste, and abuse, precision prevention, risk adjustments, to name a few. And perhaps in the provider space, we see a rapid growth in the need for modernization, especially after the pandemic, and adoption of interoperability standards and using AI and ML for a variety of use cases, such as hospital bed capacity and ICU forecasting, sepsis prediction, to name a few. A common denominator of most of these use cases that we are seeing in the healthcare space is the need to process unstructured text and PDFs, such as provider notes, lab reports, claims data, etc., which requires natural language processing capabilities to extract highly specialized clinical entities from raw unstructured text. And precisely because of that, that's why we have partnered with JSL to help our customers use JSL's pre-trained state-of-the-art natural language processing models on Databricks Lakehouse platforms. Using our technology, customers can leverage Delta Lake technology to land their raw PDF data files and the notes or images on what we call the bronze layer in Delta Lake architecture. And what this brings is, first of all, it harmonizes the format of the data that you're ingesting, whether you have image data, PDFs, or unstructured data, or even structured data that you're ingesting. And equipped with enterprise-grade security and data governance, you can bring those capabilities of a data warehouse to unstructured data using Delta. And then you can use these pre-trained libraries, such as John Snow Labs libraries for healthcare, to extract medical and clinical entities from the text and store the resulting structured data back in the Lakehouse, which would be ready for downstream analysis and reporting. Spark NLP for healthcare from a technology standpoint is built for Spark and is natively scales on Spark clusters. Since it is based on Spark ML APIs, it natively integrates with MLflow and the rest of Databricks ML ecosystem. And perhaps it's optimized for speed and memory use. Also, JSL has built a turnkey solution to make it easy to start working on preloaded clusters on Databricks with healthcare libraries. And using that, you can easily convert your workloads, from interactive notebooks to production pipelines using Databricks Jobs APIs or Notebook APIs that you can either run in serial or in parallel, depending on the dependency of the workloads. And perhaps one of the reasons that we are choosing going with JSL, other than pure technology in terms of integration with Spark, is that JSL models are state-of-the-art, have the state-of-the-art accuracy when it comes to extracting medical entities and clinical entities from unstructured text. So, going back to the architecture design that we are talking about on the Lakehouse, I briefly want to talk about it. What does it look on in a high level, and why we think that this is a really good architecture in healthcare and life sciences. So for anyone in this space that you can relate to, is the diversity in data modalities in healthcare is huge. So, depending on use cases, you have clinical and claims data, you can have structured data such as EHR data. We have other data modalities such as genomics data. More and more is being used in both in life sciences, and also we are seeing it being used in provider and payer space. And also with the rise of telemedicine, you have streams of data streams coming in, and you name it, any kind of data you can imagine, like imaging data, obviously in medical imaging, and within the medical imaging, you have a lot of diversity within the kind of image modalities that are being used. So Lakehouse is precisely designed for this, because by design, Lakehouse is designed to bring all the flexibility of data lakes and readiness for advanced analytics and AI and ML, and combine it with the governance and reliability that you would expect from a data warehouse that is, it's a technology, it's a 40 years technology, which is really great in terms of governance of your data. So data lakes, historically lack that aspect, and that's why a lot of people standardize around data warehouses within the enterprise. But now having the two together, you can take advantage of both. You can have your data landing in your data lake, which has all those security and governance measures. And then using the platform, you can now use, for example, you can use that for training and NLP models, or in case of pre-trained models with JSL, you can just load pre-trained models and use transfer learning if you need, based on your data, and all of this can be done within the platform. And then you can extract, entities or convert that to structured data. You can have this data purification factories, so that going from gold, you can extract data, land your, curated data ready for ML, for example, within the silver layer. And then further down, you extract or aggregate data, which we call it, you land it in the gold layer, that would be something that, traditional data warehouse, that then on top of that, you can use solutions such as Databricks dashboards or Power BI within Azure ecosystem to create dashboards for reporting. So as an example of one of the use cases, which is a very common use case within the payer space, is patient risk adjustment that Mo will be walking through. Just a little bit of a background on the use case. So risk adjustment And a high level is a mapping between the health status of a person to a number. And this number, you can think about it, this is a number that captures the future healthcare cost of that individual. And it is very important, specifically, especially for ACOs and at-risk providers, that to capture all pre-existing conditions for each patient so that they can get the maximum, they can get the return when they are getting paid. And this is important to note that lots of pre-existing conditions, they don't live necessarily in EHR systems, and there are things that can be mentioned in an unstructured, in a clinical note, that capturing that as the background of a patient and being able to assign that to incorporate that into your risk adjustment can really translate to a lot of return on investment and a better risk adjustment model. So a bit of background: hierarchical condition category, HCC coding, is, in fact, it's a very interesting application of machine learning and also looking at the retrospective longitudinal data. So risk adjustment model is developed by CMS that has access to all the claims data historically. And using that, they map a patient's health status due to their risk score. So you can think about it, for each ICD-10, each mapped, each code condition, you have a numerical value, the HCC score, which is, then you can use that HCC score to calculate, and this is something that insurance company are using in aggregate to have this assignment for each individual, to assign it to a risk adjustment factor or RAF score. So going from all the conditions that a patient can be coded for, and this is the conditions needs to be extracted from notes or structured data, you can get a value, a RAF score, that then can be used to predict future costs. So after this, I will pass it to Mo to walk you through the reference architecture that we have for this workload within Azure Databricks, and also walk you through the notebooks that we have created to show an end-to-end example of how you can use medical notes as the starting point of your data, and using machine learning and pre-trained NLP models to extract these entities such as ICD-10 codes, and also use JSL's libraries to calculate the HCC scores, and then come up with this assignment for each patient to be able to calculate the risk. Mo, I pass it to you now.
Thank you so much, Amir. Appreciate it. So moving on, first, we're going to look a little bit at a solution architecture, how the system that Amir has described, the business use case, looks like from a technical execution perspective, and then we will walk into the demo use case within Azure Databricks. So first and foremost, we want to be clear about the ecosystem that we are approaching here end to end. And the demo use case will more likely focus around the intelligence bucket here, but I'll walk through the end to end anyways to give you a deeper understanding on how the integration of Spark NLP for healthcare sits within Azure Databricks, which sits in the Azure cloud. So first and foremost, we care about the cloud storage. So we have a different type of medical data that comes from an interoperability standpoint from different types of sources within the enterprise, internally and externally. This particular data flows forward into a traditional ETL or ELT type of fashion, or within streams through FHIR APIs into your data lake. As the data lake is the common unified storage basically for any type of your data. This could be file-based, for example, or not displayed here, but also as an option, you would have a data warehouse type of environment that could sit between 4 and 5 as well, as you can see on this particular architecture. Recommended would be for this use case to use Azure IoT Hub for streaming, essentially, with a FHIR API that is given to you within the Azure ecosystem, or for more traditional ETL loads, you could use the Azure Data Factory to get that execution done. And then looking at number 6, you would have the option to read with Azure Synapse of these files and building your classical data warehouse environment. As you may be familiar in the industry, there is this the present state of data paradigm towards anything else you want to do with AI ML, which is more a file-based type of execution. The data warehouse here displayed as Azure Synapse would go with the traditional approach of having tables basically that deliver data to you, and the ADLS as the data lake would be the storage for your files, where basically your AI ML is happening on top. So let's dive into this a little bit. So from an intelligence layer, Amir had talked about the Lakehouse architecture. So you basically have your bronze, silver, and gold layer, where your data is basically getting prepared to an end state to extract information in case of an NLP scenario. We will have the de-identification of data first. Then we'll have a, so to speak, coded record experience where we are able to classify under certain medical ontologies, ICD codes in an example. We will see that in the demo in a second. And then lastly, we will be able to map these codes to risk, for example, that can be expressed in the serving layer. In some type of dashboard fashion. You have built-in capabilities in Azure Databricks that will help you to visualize your data. Or you could, for example, as well, use Power BI to build a more like enterprise experience to express the purpose of the data you want to serve to your business stakeholders. Again, this can happen relatively ad hoc from the gold layer, essentially, or you can go, again, the traditional route, integrate that into Synapse, here displayed at number 6, basically, and read from Synapse from like a star schema or snowflake schema, essentially. This is just to level set, so to know where we're at. For the purpose of the demo, I'm going to go one slide back just to show you we are going to focus on this, especially number 8, so that particular state. So we work with basically prepared notes that will help us to get to that HCC score and the risk stratification we're trying to calculate. So moving on, for the demo focus, ICD extraction, I just mentioned that, the gender classification in particular, age determination, also from notes, and essentially the calculation of the risk adjustment score. With this being said, I would move on now to the notebook in Azure Databricks. All right. So first and foremost, I want to present this particular notebook here. The notebook is a developed demo with Databricks and using Spark NLP for healthcare regarding the use case we're talking about, HCC coding on clinical notes. I had added a little section here, why HCC matter. Feel free to use to read this on your own time. This will give you a little bit more background on the topic of this discussion in case you're not that familiar with it, but we'll sort of like break down the purpose and why payer and provider, why they all basically use this particular calculation. From a demo perspective, let's kick it off with obviously the import of libraries, what you often do with any of these notebooks. So here, I want to point out a couple of libraries that are going to be important. So Spark NLP, obviously, and Spark NLP for healthcare, provided by John Snow Labs within Azure Databricks. Those will be the 2 main libraries that will drive this demo. First, within the use case, we are basically downloading our oncology notes. So these notes will help us to determine the risk of a member within a population. I have not displayed an example here, but again, the notebook is available for you. You can download this on your own time, and you can print out the examples and see how the exact notes look like. From a data frame perspective, actually, there's an example here. You can see this basically, a couple of these notes. So they are basically oncology statements about these members, basically, and the individual patient's age and so forth, which is going to be important for the calculation of the HCC score. So this is currently done on the bronze layer, actually, before we then move into the silver layer by having the actual HCC score calculated. As a first step, within the calculation, we want to extract the ICD codes from those nodes. So for the ICD code extraction, we are following a pipeline approach that you are maybe familiar with if you have worked with Spark MML before or other type of Spark-based machine learning libraries. There is this notion of an input and an output column and building, so to speak, a pipeline that you're executing on with your fit function. So the same is happening here within Spark NLP for healthcare. So we are basically declaring step by step each individual piece of the pipeline, each individual step of the pipeline, and then executing on it afterwards. This particular pipeline is following the approach to extract basically the text of the nodes and then making a determination of what type of ICD code it is. I'm not going to go into the details from an NLP perspective, what these steps express here. I would recommend to go into like an NLP 101 session, especially for the library, to understand this better. But basically from like an architectural setup of this particular model, you can see here we are pipelining or these individual stages as declared above here, and then running our .fit function on the data to basically apply the algorithm to the model itself. And let's visualize the output because we want to see basically how these nodes are going to be displayed. So we talked about the 59-year-old here, and we can see basically that these ICD codes are getting mapped to the individual chunks within the text. So breast cancer is identified here, or cancer in general is identified here. You also see that the ICD code is going up to the fourth to fifth characters. Sometimes ICD codes can be even more granular. Here we are doing it up to that particular level for this example. Next, for the calculation, I'm going to skip the step of assigning the assertion model for now. But again, it's something you may want to look into if you want to create a relationship between the ICD code, if it's basically a present type of disease or if it's family driven or maybe it's absent at this point. This is certainly important to determine the HCC status for your actual disease. But what I really want to get to within this demo is the next piece that we need for the calculation. For the HCC calculation, we need about 6 to 7 determining factors, essentially. Another one is the gender. So as we now have text and we do not have the gender defined in a columnar form, we need to extract it basically from the context of the node and determine it accordingly. So in this case, we are doing that with a gender classifier based on the text and then determining the gender. I want to make sure to mention here in that regard, data bias or bias in AI in general. Determining a gender based on an algorithm can be an area that under explainable AI and bias within AI needs to be determined. So I just want to make sure that from an ethics standpoint, this is mentioned here. This is purely for the execution of the use case and needs to be determined by each organization by themselves, how many genders in their actually population exist. So for this particular example, we are extracting the individual gender of the person, and we're determining based on the node here that each of these genders are in this case female. The same we are doing basically with age. So we are having an age extraction model that is running here. Again, you see basically there is the same approach of execution. We have a pipeline that is now focusing only on the age entity itself. And then we are running our .fit function on to extract that particular age. The logic of how these algorithms are executed follows over and over again the same pattern, that you have NLP tasks you are executing on. Then in the end, you have your embeddings, your near model, and then some type of conversion at the very end to basically extract that entity and display it in tabular form. Here we have, as an example, on the 59-year-old, just an example how ages are extracted from a visualization standpoint. From a data processing standpoint, we really only care about the data frame downstream. As you can see here, you see the individual nodes and the age aligned with the near label, which in this case is age. Lastly, we want to calculate the risk score. So I have displayed 2 examples here where you can basically understand on a factor of $500 and an adjustment variable how much payment per year has to be allocated. So you see the individual risk factors basically determined by age, for example, determined if you have diabetes and so forth, and how much payment per month this is going to be. The ARF is the overall sum of these prior risk factors, basically. And then in the end, you have your dollar variable, which is going to determine the payment per year per individual or per member within your population. There's a second example here. This is a little bit more extensive. You see different types of HCC risk criteria, essentially, that are mapped to your ICD codes accordingly. And you see the risk factor that is aligned with that, going all the way down to an RAF of 1.2, which is a little bit more risky. Hence, the payment is higher per year. And you see by members with a very high risk factor that the cost per year is even higher. That has to be done accordingly. From a calculation standpoint, the function of calculating this risk score is basically built into Spark NLP for healthcare. First, we need basically every individual feature that is important to calculate the individual risk. So we see first our file name here, so we can basically map this in a tabular fashion. Then we have our age, the ICD codes, basically our extracted entities, the gender, the eligibility, Medicaid, and OREC accordingly. So those will be our calculation features for the HCC risk score. We will apply basically a calculation function to the data frame with the HCC profile included, and we will come up with the row by row risk score of the individual. This is an individual risk based on this particular piece of document we had. If that member appears many times in your population, again, this risk score will basically sum up over time on a month-by-month basis, and the payment will be allocated accordingly. So this person has a very low risk score, but we know this is cancer. The person may be in this population more times to calculate than the RAF, as we have seen in the example above. You will then have a higher risk score accordingly that leads to higher cost. We are able to show this in a data frame down here for investigation or EDA processes necessary. And then lastly, once we have this data frame here, we saw this in the architecture, we can write it back to Synapse, for example, or display it within an enterprise dashboard or even within Databricks for purposes of business intelligence or, again, like I said, EDA. So this would conclude the demo for now. You'll be able to download the demo accordingly and run it on your own time. So thank you so much for joining this session. Feel free to reach out to me via LinkedIn if you have any questions or ask questions further in the chat, and we're trying to answer those. Thank you so much for joining, Amir.
And thank you so much for joining the session.
Thanks, everyone.